Alcohol mechanisms. I hope you remember that an alcohol with an OH is not a good leaving group. So you can't do substitution reactions with alcohol. Can you remind me why an OH is not a good leaving group? I'll remind you the definition of a good leaving group. The conjugate base of a strong acid is OH minus the conjugate base of a strong acid. This would be a very different world if water was a strong acid. Nobody would be alive. Okay, so water's a weak acid, therefore OH minus is a bad leaving group. You can't do the chemistry in chapter 9 with OHs that you did with halogens or toluene sulfonates, etc. That is not the right activity, sir. They're here. All right, so I'm doing a lot of talking and I'm not doing it on the video. Oh, I am on the video. I didn't even know. Sorry about that. Lost track. So one of the things you have to do in chapter 10, if you want to do substitutions of alcohols, is to make them into better leaving groups first. Okay? One way to do such a thing is to protonate it, because water is a good leaving group. Question 1, what's water's conjugate acid? Water's conjugate acid. Acid has one more proton. H3O plus. What's the pKa? -3. By definition, what kind of acid is that? So water is the conjugate base of a strong acid. Water is a good leaving group. If you protonate an alcohol, you've made it into a better leaving group. Blah, blah, blah. Okay? Well, here's the story. Lone pair. Strong acid. That is not a good arrow. There we go. Another strong acid. It was a rather curvy arrow there. Now these are different. One's secondary. No. Whoa. I didn't put the O in the right spot. I was looking ahead. My bad. There. And new H makes that an oxonium. Secondary RX. I can call that RX now. It's got a leaving group on it. What do leaving groups do? They leave. Now, you can't just make them leave willy-nilly. You got to realize secondary carbon they can leave, because the secondary carbocation is okay. I do not want you doing that with this alcohol. Do not do it with this alcohol, because if it leaves and makes a carbocation, what kind of carbocation would that be? Primary is illegal. You are now no longer allowed to draw primary carbocations ever. They're haram. Don't draw them. So you don't have that option over there. What are the other products here? Cl minus is the other product. Br minus. I think we can finish this one off. This is a primary Rx. This is a strong nu. What are you thinking? You're certainly not thinking SN1 carbocation. Not with a primary carbon. So what's your other option? SN2. How do the arrows go for SN2? What are your buzzwords for SN2? Backside attack. You just described the arrows perfectly. Backside attack, leaving group does what leaving group does, it leaves. Done. Love that mechanism. Now, how the heck am I going to get the chlorine on the tertiary carbon when the tertiary carbon's not a carbocation? Yet. Hydrogen shift, that was a good answer. Yeah, carbocations, shifts. This stuff never goes away, apparently. Now you got your tertiary carbocations. Time to light it up with a Cl minus. Boom. Good activity. That's a tertiary Rx, you know, you made that, and here's a primary Rx, different Rx. Yeah. So we can make alcohols into more useful things, although alcohols by themselves are useful, like they're good target molecules sometimes. And that's the end of that one. Yes, sir. You are not allowed to make a cation that looks like this unless you enjoy getting comments like this. I'll even add this word. Yeah, primary carbocation is, no, it's your German, verboten. There you go. How many languages can we give forbidden in, you know? Yeah, the sin. Oh, wow, going deep there. Oh, you're sticking with the ROM theme. I like it, yeah. Okay, so, yeah, I don't know. I just don't want to see such nonsense. Hope it's clear. All right. Done.